Welcome to lesson number 32, Learn C programming on the Raspberry Pi. Okay, well, the last couple of lessons we were discussing pointers, and today and probably for the next lesson or two, I'd like to talk about file I/O. So let's get right to it. We'll go over to the Pi and we'll go to our lessons, and let me make a new directory here, lesson-32, lesson-32, and we'll start Genie. And we'll just briefly go over what we did last day, the highlights anyway. We're looking at arrays, and we were looking at how the array name can be associated with pointers, or can be how we can use arrays and pointers almost interchangeably. So we learned that the array name by itself is the address of the beginning of the array. We also learned that the address of the first element is also the address of the beginning of the array. In fact, we also learned that the address of the array name is also the address of the beginning of the array. So we can say these three items are more or less identical. Okay, so let's start talking. Let me close all this stuff up here, and we will make a new file. And I'd like to start talking about file I/O. Well, let me first open up our notes here. Recent files. Do I have my notes somewhere? Yeah, right here, notes. I'd like to just go down to maybe just start a new topic down here called file input output. And the most important concept right now, at this stage anyway, is to realize that there are two kinds of files that we can deal with in the C language. One, we have text files. So files that we can view, for example, with the, let's say, with cat or the more commands. Okay. And number two are binary files. So with binary files, we can't really look at them with cat or more, but we can display their contents using OD, using the OD command or octal dump. So I'll save this guy here, and then we will make a new file. And let's just call this one, we'll call it text read, or just T read. Actually, I'll put this in first. I'll just save this guy as T read or text read. Save as, and I'll put it into lesson 32, and I'll call it tread.c or textread.c. Okay. So, well, the first thing is, if we're going to read a text file, then we need a file to read. So I'll make a file up here. I'll just call it, for example, I'll use the vi editor here. I'll just call it file.txt, text file. And I'll just put in some numbers. Let's say 23, 12, and 61. And then on another line I'll put a couple of numbers, 9 and 75. And then on the last line I'll just put in the number 56. So this file I just created here, file.text, you can see I have 3 lines. On the first line I have 3 numbers. On the second line I have 2. And on the third line I have 1 number. And I can view this file using the cat command, or I can say more file, and I can see it with the more command or the less command. And so it's perfectly viewable by a human being. So let's see if we can read this guy. Well, the first thing is, in order to read that file, well, let me put it down here so we can see it. What I'll do is I need a file pointer. So I will say, this is something new now, star FP. FP is going to be a pointer to that file. In fact, I can, right on the declaration line, I can open it up. So I can say f open, and I want to open, and the name of the file is going to be file.txt, and I want to open it up in read mode. In other words, the file exists and I just want to read it. Now, if that command is successful, then FP will be a pointer to the beginning of that file. Okay, and this data item here is declared for us in standard.io.h, so we don't have to worry about it. We just have to know that FP is a pointer to a file. In fact, it's pointing to this file right here. So we're going to open it up in read mode. Well, now that we have it, we can read that file. Well, I need an integer to be able to read. I need a loop counter, or maybe not a loop counter. I can just do a loop like this. Let's say int, well, let's call it x. That's what I'm going to be reading. Now I'll say, let me see if this works. While I'll say not FEOF bracket FP. Okay. So what I'm doing here is I'm saying, while I do not have an end of file on the pointer. So long as I have not reached end of file. Okay, so I'll just put in here continue loop until end of file. Okay, so let's take a look at the loop we have to do here. Well, we have to read in an integer. So I'll just say, instead of scanf, normally just say scanf, like this. We want to just read, and I put in, for example, %d. I want to read in an integer, and I want to read it into the address of x. This is normally how we would just scan from the keyboard. But in this case, I want to read from the file. So instead of scanf, I have to put fscanf, and then I have to put in here the file pointer, like that. So I'm scanning now from the file. This is the pointer to the file I'm scanning from, and I'm scanning an integer. And now when I scan that integer, I can just print it. Printf bracket quote, and I'll print x is %d / n quote comma x, like that. And that's the end of my loop. Well, when I hit the end of the loop, I should close the file. Fclose fp. Okay. And that's it. Just want to read some integers from that file. So I can save this guy, and let's give it a try. So I'll say C99 tread minus O tread, and it compiles okay, and now I can run it. Tread, and you can see I read in all of those digits. In fact, if I cat file.text, you can see the first one is 32, then 12, 61, 9, 75, and 56. Oh, I have two 56s. How come I got two 56s? Two 56s. So I did that twice. Well, then perhaps we should have just did the first read on the outside, like this. Make an initial read here, and then what we'll do is we will put our print here, like this, and this print we will remove. So now we do our initial read. If we have not hit end of file, we can print X, and then we do our next read. So let's try it this way and see if that solves our problem here. I will compile it, and then I will execute it, and now we only get one X equals 56. So this is probably a better solution than we had before. Okay. In fact, I could even take those x's and I could put them into an array if I wanted to. But I won't bother doing that now. I just wanted you to get a feel of how to read a text file. Well, if we wanted to write a text file, we would do something very, very similar. So let's give it a try. I'll make a new file here, and let me copy some of the stuff here. In fact, I'll copy everything here into my new file, and this file I'll save it. I'll say save as, and in lesson 32 I'll just call this guy, I'll call it text write.c. So this will be my file for writing. So in this case here, I want to, instead of reading, I want to open the file with write permission. So let's call, this is going to be a brand new file. So I'll call it, maybe I'll just call it new file. And I'm going to open it up with W permission. And now what I want to do is I want to just do a loop here. I just want to do a loop. Well, let's take all of this out here. Let's take all of this out, and I'll say for bracket int I equals, let's say 12, I is less than 20, I plus plus. I'm just going to make a loop here to write to the file. So instead of printf writing to output, let me just say quote percent d, and let's say I wanted to put them all on different lines, so all my numbers will be on a different line. I'll just do it like that, and I'll write out I. So this is the way we'd normally write to standard output, but now I want to write to this new file. So I'll use instead of printf, I'll say fprintf. And of course this time I also need to put in the file pointer that I want to write to, just like that. And then at the end of that loop, we can close the file. Okay, so let's see if we can compile this guy. Let's see, it's text write minus O text write, and it does compile. And if you look now, we don't. I'll run it and we'll see if we have that file created like this, and there it is, new file, cat new file.txt, and there are my numbers. So this is a text file, and you can look at it, you can read it, and it's just basically how to work with text files. And you can write out strings of characters, you can write out floating point numbers, you could read float numbers, you could write characters, read characters this way from just plain ordinary text files. Okay. Well, the next thing is to do a binary file. So let's first try to just write out a binary file. So I have to create a new file here, and just for now we'll do something similar, and I'll just do this, and I'll save this guy, save as, I'll put it into lesson 32, and this time I'll call it bwrite.c, binarywrite.c. Okay. So what I'm going to do this time is I just want to write out one integer. So let's say x equals 1, 2, 3, 4, one integer. So first of all, I need a file, so I can say file star fp. Okay, and this time I'm going to open it using the again f open. And I will call it, let's say I'll call it, file.get bin. It's going to be a binary file, and I want to give it permissions of write binary. I think that's the way it goes. We could check that with the fopen man page. So I could go here and say man fop open like this, and you could see fopen says you give a path to the file you want to open, and then the mode you want to open it in. So if we look further down the man page, we can look for the mode, and the modes are here. All these characters here are the modes. Like R means I want to just read. Let's go further. I don't know where they give you the other ones. Back. Binary. Right, treat files binary. Not found. It says see notes below for extensions of the mode. So where are the notes below? Notes. Here we are. But I don't see it here. Well, let's just try it and see what happens. So what I'll do now is I'll say instead of fprintf, I'll say f write, and this time I have to tell it where I'm going to write and what I'm going to write. So let me just look at that man page. Write. So write reads this number of elements, the size of each element. The stream is the last thing, and where to get the data from is pointer. So I want to write from the address of X like this, and I want to write what's the next thing? The size of one element. This is a 4-byte integer, so I want to write 4, and then how many of these am I going to write? One of them. And where am I going to write them to? FP. Like that. So now I'm writing a binary file, and I don't even need to put that in the loop, just one guy by itself. And when I finish the write, I can say fclo close FP. So I just wrote out that one number, and then return 0. And that's my whole file for writing out a binary 1, 2, 3, 4. So let's save this guy, and let's see if it compiles. We'll see if I got this right, or maybe I got that wrong. Anyway, we'll try it. So I have this guy called bwrite, binary write.c. So let me compile it. C99 bwrite.c minus o bwrite, and it seems to compile okay. And I remember I'm writing it to a file called file bin, which right now there is no file bin here. So let me just try to execute it. This is called bwrite, and it wrote something, I guess. And if I look, you see the file bin is that. Now if I try to cat it, it just gives me some nonsense here because it's a binary file. You can't really see it properly. But we can use the octal dump command, bin, and we can pipe that to octal dump. And what we'll do is we'll look at it in hexadecimal notation. Okay, and there it is, 04D2. So that's supposed to represent somehow 1, 2, 3, 4 in binary. Well, let's take a look at that. First I'll try the BC command. This is the Linux calculator. And what I'll do is I'll select my input base, IBASE, to be 16. My input base is 16, and I'm going to type 04D2. By the way, in BC, for hexadecimal digits, you have to use uppercase letters. Okay, so I type in 04D2, and it says 1, 2, 3, 4 in decimal. Okay, so how does that actually work in reality? Well, let's take a look in binary digits. I'll bring up this paint program here, and let's see. Well, first of all, I want to get that number in binary, so I'll say input base is 16. Let's say Control D. I'll start BC again, and I'll say O base, output base is 2 binary, and I want to know what 1, 2, 3, 4 is in binary. That's it in binary. So it's 1. Let me try this here. Let me show you this. So it's 1 and 2 zeros, 0, 0, 1, 1, and then another 0, and then a 1, and then 2 more zeros, and a 1, 0. So this is supposed to somehow represent 1234. Well, let's break that down and see what we get. Remember, this in binary, this first digit here represents the 2 to the power of 0 position. The next one is 2 to the power of 1. The next digit is 2 to the power of 2. Next one is 2 to the power of 3. And then I'll just write in here 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2 to the power of 10. Okay, well, 2 to the power of 10 I know is 1024. That's 2 to the power of 10. And then I have 2 to the power of 7. Well, 2 to the power of 10 is 1024. 2 to the power of 9 is 512. It's half. And then I have 256, and then I have 128. So 2 to the power of 7 is 128. And then 2 to the power of 6 is 64. And then 2 to the power of 4 is 16. And then 2 to the power of 1 is 2. Let's see if that works out. If I add all this stuff up here, I'll get 8 and 4, 12, 16, 22, 24. 4 carry a 2. 2, 3, 9, Let's see, this meant 4 and 6 are 10, 11, carry the 2, 13. So now I got to carry 1 and 2 here and 1. So that binary number is 123 or 1234. Okay, clear as mud. Let's now go and well, I don't need this anymore. Let me do away with that. Discard. What I want to do now is let's see if we can read that guy back. Well, I'll make another file here, a new file, and well, let me just copy all this stuff into it here from my right. I'll just copy that into there. Excuse me. This time I'll save this guy as, I'll call it save as binary read in lesson 32, and I'll save it as bread.c. Okay, well, in this case I don't know what x is, but I'm going to open this guy now for reading in binary. And this time, instead of fwrite, I'm going to say fread. Read. So, in other words, I want to read from this pointer. I want to read one item, and that item is 4 bytes long, and I want to put it into X. And after I close the file, I want to printf, quote, the value of X is %d/n, quote, comma X. So I'll just print out what I read. So let's save this guy. I'll try it. 9b read minus o minus ob read, like that. And I'm going to be reading the same file that I had, this file.bin /b read, and it says the value of X is 1234. Okay, so so I have two files here. If I look at cat file.txt, I can see it. Cat new file.txt, I can see it. But if I cat file.bin, it's binary, and it just shows me some little garbage in here. Okay, so just going back now to our notes. Text files that can be viewed with cat or more commands. Basically, text files are just, I could say, they're encoded using ASCII codes or the table. Okay, and that's why we can read. We can look at text files and we can read them because they're just encoded as ASCII, whereas binary files are just encoded in binary. To be honest, all files on the hard drive or in RAM are all in binary. They're all ones and zeros. So it's just a matter of really understanding the subtle difference between a text file and a binary file. So I'll save that guy, and I think this is probably good enough for this lesson. What I'd like to do in the next lesson is get back to the Pi and see if we can actually do a project on the Pi. So until then, thank you very much, and we'll see you later for lesson